One more remaining part on our agenda is assignment 1, date towards conversion. So the purpose of this assignment is to experiment with Java strings and arrays. So we begin by downloading the demo code from CIS257 sample code, and the demo that we need to download is date towards demo. So before I start this download, because I need to compile anyway, I will actually create a new project, file, new project, again Java with and I'll use A1 for the project name. Of course, I will not attempt to create the main class, because this time the main class will be downloaded from the sample. Okay, so I just click finish, so this will give me the empty project with no source package defined in our project configuration. So what I would like to do, date towards demo, it's this demo right here, pretty much at the top of our samples page, and I'll be just right-clicking download to download the files. But first let me take a look at the actual package name. So the package name is A1 demo. So I'll just go ahead and create this A1 demo package inside of my project to keep things simple and make things compile right after I download everything. So I'll just go to my source packages and add Java package and give it the name A1 demo. So now that I have A1 demo in place, let me take a look. So the project name is A1, source A1 demo, and so this is the path where I need to be downloading my files. I'll just copy it from this address bar in my file manager view. And so once again, these three files that we need to download. So right click, save link as, and specify the location of this, and this matches the location that I chose for my project, and here's the package name. So this subdirectory here is pretty much the package name. So we save the Java files. Make sure that you save the Java files and not these links, because these are links to HTML pages, but we need to right click every download and save as. And so I do it 3 times. And so this is our source code from this demo page. Okay, so everything is here. Let's just make sure that we can build this without any errors. So I'm just going to say clean and build and observe if everything works fine. So my output tells me that build was successful. Just be sure that this is also your result just after you download these files. So here's what we need to do with this prototype. The prototype is already asking the user to enter a date in the common format, month, day, and year. So then we need to convert the date to its word representation as follows. We need to print English name of the month. We need to print English representation of the day. Basically, we have to print words, 1st, 2nd, 3rd, 31st, and so forth. Print English representation of the year, and this year will be composed of 2 parts. The century part ranges from 10 to 99, and the year part is in range from 0 to 99. So essentially, let's take a look at some of these examples. So that the user is typing 12/12/2012. Then the output goes as follows: December 12, 2012. Right. So 20 right here is the century part. Right. So this is the century part, which is from 10 to 99. And the year, the actual year within the century, is from 0 to 99. So here we print century as 20, and 12 is the year within century. Okay, so this is the basic idea. You can read this description, and let's see what this example already does. So I'll just, since I already built this prototype, I'm just going to run it. It asks me for the main class, so I'm just going to accept this. And like I told you, it already does this part that it just basically says enter a date in a certain format. So I can try entering something like 1/31 2021, okay, something like this. And you see it already does the work quite nicely. So it prints January, so it knows how to convert 1 to January. It ignores 31. We need to be printing 31 or 31st, whatever the choice is. And then it already prints 2021. So the year conversion to word representation is already done. Perhaps as we make our adjustments, we need to add this comma in the output format. Right here, the comma isn't printed. And then goes right back to the initial prompt. So let's take a look at the main method. So it's trying to get the input from the user, and it does everything in this endless loop. So it would be nice to have some way of maybe quitting from this program. You can think about it. Maybe if the user enters 0 or something like this, it would be helpful to exit the program. So right now, if I do this, it actually prints bad input and says retry. So anyways, let's just stop this program by clicking this X right here and see. Okay, I'm just trying to catch my X right here. You would like to cancel? Yes. Okay. So the task is, so let's take a look at the main method very quickly. So what we do, we enter string in this format using the validator class that allows us to enter non-empty strings. Then we use this very helpful method named split inside the string. So once we enter the string, you can see that we call the split method, and the split method essentially returns back an array of strings that is generated based on a delimiter that we specify. This delimiter is actually a regular expression, but right now I'm just using a very simple pattern here, just a /, which we're expecting from the user. Then notice how we quickly check the length of the return array and making sure that it's 3. Basically, we're expecting month, a year, a month, day, and year. Total 3 parts. If there's something wrong with this format, we should be able to tell the user right away. And this is what I've tried by just entering 0, and this is the response that I had, and continuous statement allows us to go right back to the initial prompt to get the new string. Now, if we know that we did get 3 parts, what we do is that we use integer parseint, and we do this 3 times for components 0, 1, and 2, the array that was returned by the split method. And supposedly we get our month, day, and year. If there is something wrong with these values entered by the user, of course parseint will throw a number format exception, and we should be able to warn the user right here that we expect numeric values and not like January in place of month or some other variations of that. And so we tell the user, and again we let them re-enter. And the actual work of conversion from numeric format to words, which we partially do, in this sample prototype that we use the converter class, and we say, okay, let's create new date-to-text converter. So it's this class right here. So we'll have to examine this class. So what this class does, it already has, so its constructor apparently does the necessary conversion to this to internal format, and then the converter has three methods: month to text, day to text, and year to text. And we're just printing individual pieces right here, and then we go right back to initial prompt. So the work that we have to finish here, I'll highlight the parts in this prototype that you have to finish. So for now, I'll just close my project and move this to the separate document group. So the work that we do with this class DataTextConverter is pretty simple. We just create the object from the three integers that we already parsed. So we have month, day, and year, and this is the constructor that is taking three of these. And internally, it stores the data as month, day, and year. So then we have these three methods: month to text, day to text, and year to text. So let's take a look at these three methods. Okay, so the first operation is month to text. So remember that the converter already has three integers that are correct. We're expecting correct month, day, and year. And here I'm just using the switch. And of course, the switch works for January and February, but it wouldn't work for March, April, and so forth. So you need to essentially finish the switch statement to do to handle all months. And of course, you can always keep the default, which will print the invalid month in case if it's out of range between 1 and 12. So here's the date to text. So the date to text is completely unfinished. So it does return a string, which is what we expect to print, a string. But it just basically takes the day, which is an integer, and converts it to string, which becomes still, you know, printed as digit. So this is completely unfinished, and we have to change this. So this is year to text. So year to text, what year to text does, year to text is completely finished, and it already works. So according to the requirements right here, we said that we want basically to print the century part and the year part inside that century. So the century is obtained by year, which is integer, divided by 100. And the year and century is obtained as taking the year and divided it by 100, but then taking the remainder of that division. So we say then the string version of the century is numbered to words, and the year is also numbered to words. So the key part of this conversion is the number to words method, which also exists here. And remember that there was a requirement to insert the 0 suffix when printing single-digit years. So here's that part that basically says if year and century is less than 10, we need to insert the 0. And so what we return from our year conversion is the combination of century text plus optional suffix like this and year. Okay, so this completely works. So we have this number to words conversion method that does all the magic, and it's based on two static arrays of strings. So I call this vocabulary. So this vocabulary is made up of words, right, which represent the numbers. So 0 to 19 is simply a list of all all values from 0 to 19. So you have 0, 1, 2, 3, and then 10, 11, 12, 13, and so forth, 17, 18, and 19. So in the range from 0 to 19, we have all of our conversions directly in this array. We also have the decades. Okay, so the decades are called 20, 30, 40, 50, and so forth. So these are the list of decades. And this is where the magic happens in this number to words. So what we do here is we say that we want to convert to text a number in range from 0 to 99. And this is what we do. If the number is less than 20, we just take the value directly from this array. So it's 0, 1, 2, 3, 4, 5, all the way through 19. We simply use this number as index to obtain it from here. If it's greater than 20, then we say, okay, if this number is divided by 10, and it can be divided by 10, this is the remainder operator, and the result is 0, it means that it's evenly divisible by 10. If that's the case, evenly the number that we were giving in the range from 0 to 99 is evenly divisible by 10, we go straight to the decades. And what we do here, we take the number divided by 10. So it becomes 0 through, whatever, divided by 10. And then we reduce it by 2 because 0 here is already starting at 20. And this is why if the outcome of this is 0, we're going to get 20. So see how we progress from 19 to 20 because we take the number, we divide it by 10. So let's take a quick example of this. For example, arbitrarily, if the number is 20, okay, so the original number right here, number is 20. So what's going to happen? It's not less than 20, so we divide it by 10. And of course, when we divide it by 10, I'll just write it right here, and take the remainder of that division. Of course, 20 divided by 10 is 2, and the remainder is 0. So this gives us 0. So the remainder of the division is 0. So therefore, it equals 0, and this is our case. So we will go directly to the decades, but we need to find the correct position in this array. And so what we do, we take this number 20. Okay, so the next step is on this line right here. We take 20 divided by 10. Divided by 10, like this, right? So the result should be 2. And the 20, which we would like to make printable as a word, of course, it is at position 0 in this array. So this is why we subtract 2, because we know that the smallest value here starts at 20. So then we take 20 minus 2, so this is the second part of this expression, and minus 2, of course, the result is 0. And so this 0 we use as index into decades, right? So we take decades and we use this result of this computation as index, and at index 0, right? So we have the outcome is something that looks like 20. Okay, so this is what we get as an example. So you see that if these conditions are met, we end up being right here. But if the number is not evenly divisible by 10, such as, for example, we can take 41, right? 41 as an example. 41 divided by 10, and taking the remainder, of course, 40 divided by 10 is 4, and 1 is the remainder. So in this case, we go to this portion right here because we check the value, And so here what we'll be printing is 21, 22, 23, and all these numbers. So the formula is that we continue to use the decades, okay? So we do the same computation, and this time it's number divided by 10 minus 2. So of course this index into the decades becomes, if we take, so what we do here is that we take 41 divided by 10, which will be 4, right? And then we minus 2, we subtract 2. So the index becomes index 2. And then we go to an array index, right? So as we did over here, so we go to decades with index 2. Right, so we go to the decades index with this value of index that we just obtained, index 2, and look what it gives us, 40. Okay, so we get 40 from here. Okay, so this is nice. So this gives us 40, just like this. And then what we do, so this is the first part of this construct, and the second part that we add space right here, and then we say, oh, the remaining portion of it is within range 0, 1, 2, 3 through 9, and we simply go to 0 to 19 and just simply divide our number by 10. So this final part here, we will take 41 right here in this place. We divide it by 10, but we take the remainder out of it, and of course it's a 1, so we jump directly to 0 to 19 with index 1. So of course this, when we use this as index, and this time it's 0 to 19 with index 1, and so of course this gives us output 1. Right? So this is what happens in this part, and we concatenate everything together. So this is the result. We take 41, we do all these checks, we basically use parts of these predefined arrays, and we are able to conclude that this should be 41 with this space in the middle. Okay, so this number two words works very well, and I will show you this hint that if this data text which is unfinished, all we have to do is just simply return, right? So I'll change this to return number two words. We know that the days in range from 1 to 31, and so this is all we have to do is just return this, and it should work pretty well. So let's check this very quickly. Let's try this again. So we'll just run again. We'll type 131 2021, something like this, and you see how January 31 instantly came out just very nicely from this single change date to text. Okay, so basically this is a very little change, and your task perhaps is to understand, review what this number two words does and how it works. All right, so then of course you should be able to finish this portion, and that pretty much it from the first challenge right here, to be able to print all of these strings. But the remaining challenge is to make sure that all of the above requirements are met first, like we discussed right now, and then add code to validate the enter date to make sure that the month range is correct. So it has to be from 1 to 12. So you need to add logic somewhere in your code to make sure that the month entered is a proper month and not just some kind of random value outside of the appropriate range. Then verify that the day range is the day inside that month is correct. If not, tell the user, and of course you can switch on different months to do your checks. February, of course, is a little tricky because this is where the leap year comes into the picture. So the leap year will have 29 days, and I'm giving you a sample method that will return true or false based whether this is a leap year or not. So this is what I'm asking you to add as a final. So this is the biggest part of your assignment on your part. Finally, what I'm asking you to submit, just your Java source files. So this is my project right here, A1. This is NetBeans project. So of course, if you just take your source and then you can make a zip file and submit as a single file as a result of your work. So make sure to use the discussion forum if you have any questions. Share your thoughts and help other students with this assignment. So good luck with your first assignment, and this is what we have on our agenda for our first week.